This is an illustration of section Learning Objective 12-1. The exercise is explained in the textbook. Is about US Route 25 and Interstate 75, two different routes, and we're interested in knowing whether the two variances are the same or not. So the null hypothesis is that the two variances are equal, and the alternative is that the two variances are different. Well, one thing we can do to start with is just calculate the variance of each case. Okay, the US 25 variance and the variance of I-75. And we just type equal VAR and then S dot S because it is coming from a sample. So it'll be B4 from B4 to B10. Okay. And the next one is the variance dot S from C4 through C10, C11. And clearly the US 25 is larger than the I-75. So in this problem, the F test or the test statistic or F ratio is simply the ratio of the two variances, and that is our test statistic. Okay. Test statistic is equal to the ratio of variance 1 and variance 2 with the highest on top. Remember, in the numerator you have to put the highest variance. So the test statistic is for 22.6. Now the alpha is 0.10. So if we go to our tables, keep in mind that this alternative means the two variances are different, so it's a two-tailed test, but in the F test, in the F distribution, we just use one tail. We start at 0 here, can never be negative. So the upper tail is 0.05 because it is a 0.10 alpha. And there is then a critical value of F here given the degrees of freedom in the numerator. Let me just call degrees of freedom 1. Since the sample size is 7, here 1, 2, 3, 4, 5, 6, 7 items, then the degrees of freedom are 6, and the degrees of freedom in the denominator are 7. 8 minus 1. So all we need to do is in our table, the numerator degrees of freedom, remember, are 6, is right here, and the denominator is 7, so the critical value, I'm sorry, the yes, the critical value will be 387. So from the table, we know that the critical value is 387. However, that same value, we can calculate it. Let me put here critical value using Excel. And it's very simple. You just type equal F. And if you recall from all the distributions, if you type DIST, you get a probability. But if you type INV, inverse, you get a value, a t value or a z value, or in this case an f value. So we type f, I, and v, and then if you notice we have the option RT, which is right tail. It says it returns the inverse, that means the f value, given a specific probability on the right tail. And of course the degrees of freedom. So we open parentheses and specify 0.05, and the degrees of freedom are again 6, and 7. And notice we get the same result, 3.87, a little more accurate. Now the decision is based on whether the test statistic is greater than the critical value, and if you notice it's 422 or 423 versus 387. So if the test, given that the test statistic is greater than the critical value, then we reject the null hypothesis and conclude that the two variances are different. Now something else you can do, which is simpler, even simpler and faster, you go to data, click on data analysis, and then select F-test to sample for variances. Click OK, and you have a variable 1 range. Click on the red arrow. That will be use 25. Then click on the second arrow, I-75. And then here the labels, you need to check labels, because I'm including the labels. If you don't, then you don't need to check. Then the alpha is the upper tail that you need to specify here. This is 0.05. And in my output range, I want to check, I want to get it from that cell, E13. Click OK. Then you get the results. Notice I get my two means, the two variances, which are almost, the same as the ones I calculated here. Degrees of freedom, 6 and 7. The test statistic is 422, 423. The critical value is 386. And of course, we have to reject the null hypothesis. And finally, this is the p-value. Since the p-value is less than alpha, less than 0.05 in this case, then we reject the null hypothesis and conclude that the two variances are different.